Last night in a KCRA3 investigation, we showed you how the U.S. Forest Service studies the effectiveness of aerial attacks on wildfires. It comes as the cost of fighting wildfires has skyrocketed, in part because the cost of using planes and helicopters. The rimfire alone cost taxpayers more than $95 million to put out.
Tonight, KCRA3's Kevin Oliver shows us how researchers are taking a new look at fire and what causes it to spread from one place to the other.
Humans have been trying to control fire for hundreds of thousands of years, but researchers say fire is still not completely understood. We travel to the one place in the country where scientists are trying to get a better understanding of how fire behaves so they can learn how to better predict and control it in the wild.
Fire when ready.
Fire, being able to start fires and put them out, was a turning point in human history.
Fire is one of these things where there's so many things to study, so many unknowns.
And yet, despite all kinds of technological advances, fire is still not completely understood.
So this facility was built in 1960 and as one of 3 fire science laboratories in the country. And the whole point of it was to understand fire behavior, fire ecology, for the purposes of managing fire better.
Mark Finney studies fire for the U.S. Forest Service at the federal government's one remaining fire lab. We traveled here to Missoula, Montana to learn more about what they're finding. Using high-definition cameras and sensitive instruments, researchers are able to dissect a fire and study how flames move and behave under different circumstances. In what might look like random flickers, they are finding patterns.
So what do you see? Puffing.
With students visiting from Idaho and Montana, the researchers demonstrated the flames have a natural, measurable, and predictable pulse created as hot gases rise into the air. The larger the base of the fire, the slower the pulse.
When you have a fire, what it does is creates a lot of hot gases. Okay, flames are part of that, and they're just the visible part. But the hot gases are low density, right? Just like in a hot air balloon.
It's one pattern that helps researchers predict how fire moves. Here the fire is rising, confined by the iron pan. But what happens when you start a fire where there is room to spread? In a wind tunnel at the lab, researchers have set up a $5,000 experiment. It's a controlled burn like no other. Instead of burning pine needles or grass, they're using uniform pieces of cardboard cut with a laser beam so that they can measure exactly how the fire travels from one end of the wind tunnel to the other. With high-definition cameras, they can slow down the video and track how lightning-fast surges of flames move forward and retreat, eventually igniting neighboring fuel. Eventually, you can see how the fire spreads across the entire bed of cardboard. Sensors also measure quick bursts of heat and energy as the flames get closer. Finney says he's noticed a swirling motion that causes part of the flames to move up, which pulls in air to force another part of the flame to dart forward, which is how it can spread even with little or no wind. By better understanding how fire spreads here in the laboratory, they can better predict how it will move in the wild. Finney points out similarities found in grass and forest fires. A crowning tree will puff just like the pan of burning alcohol, and a grass fire will have a similar series of peaks and troughs as found in the lab.
In order to manage fire better, we need to understand it better, and those are still the same arguments today.
The research isn't going to lead to some magic invention that's going to be able to stop fires.
We can see now that a lot of the flame has kind of died down.
Scientists like Shirley Zylstra, who is studying the effectiveness of fire retardant, says even retardant isn't meant to put the fire out, just slow the fires down and allow firefighters to get ahead of it.
I can't imagine there will ever be a chemical that will do everything that we want it to do. There's always going to be trade-offs.
But Forest Service researchers believe the work here will pay off in the field.
If you understand it, you can probably predict it as well as you can, right? If you don't understand it, you certainly won't.
The research is far from over. Scientists are testing new tools and new methods for fighting fires, and they're already incorporating what they are discovering into firefighting training and management. Back to you.
Really fascinating. Well, if you have an idea for KCRA3 Investigates, you can email Kevin Oliver or Brian Heap at KCRA Investigates@kcra.com.